Okay, so again, page number 37. So remember that tomorrow you guys have a quiz, but it's only on 5.1. It's only on 5.1 and 5.2. So this stuff will not be on the quiz. Okay? The stuff that we're doing today will not be on the quiz tomorrow. So tomorrow's quiz will be on multiplying polynomials, factoring by a common factor, including factoring by grouping. So that's what you have to know for the quiz tomorrow. So we've seen that the very first type of factoring you always look at is looking for a common factor. And then we saw that sometimes when you have four terms, you can factor those by grouping. So we're going to start looking at a new type of factoring today, Keen. And that's factoring certain trinomials. Remember, a trinomial is a polynomial with three terms. So we're going to start looking at factoring certain types of trinomials by working backwards. Remember, when you factor, you're trying to find something that multiplies together to get what you start with. In the case of polynomials, you're trying to find two or more polynomials that will multiply together to get what you originally started with. And we could always check by multiplying. And we did that, right? So we're going to do this by starting by multiplying some polynomials together, see what we get, and then we can go back the other way and say, okay, the answer we get when we multiply it out will equal the original factors that we started with. So this first example, it says multiply the following. The first one is x plus 1 times x plus 3. Those are two factors. Remember, factors are things that multiply together. So these actually are two factors. X plus 1 is the first factor, x plus 3 is the second. And you might remember in Math 9, you were introduced to algetiles. So if you want to multiply x plus 1, I'll put that on the top, by x plus 3, I'll put that on the side. Okay? So with these algetiles, and I'm just going to move these over a little bit so I have room to put my algetiles in there. With these algetiles, there are two different colored tiles. The dark ones represent a positive tile. The light ones, or the ones that aren't colored, represent a negative tile. Also, you might remember that the large squares represent an x squared. So this would be a positive x squared. And the one that's not colored would be a negative x squared. The tall, thin rectangular ones are x tiles. So the colored one will be a positive x. The one that's not colored would be a negative x. And we're going to see sometimes these tiles are vertical and sometimes they're horizontal. That doesn't change the fact that the colored one is a positive x, the uncolored one is a negative x. And the small squares represent a value of 1. So the colored one is a positive 1, the uncolored one is a negative 1. So if you want to multiply positive x plus 1, it would look like this. There's our positive x, here's our plus 1. So across the top, that represents our positive x and our positive 1. And on the side, we're also going to have positive x, but then the other part of it is a plus 3. So a positive x on the side, that will be a vertical one. And then a positive 3 means we have to have 3 positive 1 tiles. Each one represents plus 1. We'll have 3 of them to get our plus 3. So this is how you would multiply together x plus 1 and x plus 3 by using algetiles. So the answer will be what is going to be on the inside here. And we're going to build the answer by moving some shapes down into the inside part. And to decide what those shapes look like, each shape will have the same width as what's directly above it, the same height as what's directly beside it. So if I want to fill in this first space here, I'm going to have to put in a shape that is the same width as what's above it, the same height as what's to the left, which means I would have to put a big square in there. It has the same height as what's beside it, the same width as what's above it. And also, because the one on the top is a positive x and the one on the side is a positive x, a positive times a positive is also a positive. So that's why we have to use a colored tile when we bring that down. To see what goes in this space to the right of the one we just did, again, we're going to put a shape in there that has the same width as what's above, the same height as what is on the side. Okay, Keaton? Put your phone away, please. So the same width as what's above, the same height as what's to the side would look like that. Again, it's a positive on top, a positive on the side. A positive times a positive is a positive. So next I'm going to fill in this space below the big square, and I'll fill it in with something that is the same width as what's above, the same height as what's to the left on the side. So that one would look like that. Same width as what's above, same height as what's to the side. And again, it's a positive times a positive in every case here. So all of these tiles that we're moving in there are going to be positive. They have to be colored. To fill in the space to the right of the one we just did, again, you're going to fill it in with a shape that's the same width as above, the same height as what's to the side. It's going to have to be a small positive 1 tile. And now we'll fill in the rest of the spaces doing the same process. Same width as what's above, same height as what's to the side. And what we're building here is we're building a shape, and if you take all of those pieces together, it's like one big rectangle. And that will always happen. They'll go in there and they'll build, Peyton, Peyton, take your earbuds out and keep your phone away. So when we put them in there, they're going to form a large rectangular space. And what is the value of all those tiles? So we can now write our answer. Okay? We've got a positive x squared, and then we have 1, 2, 3, 4 positive x tiles. So that's positive 4 x's. And then we have 3 positive 1 tiles, so that would be plus 3. If you multiplied out x plus 1 by x plus 3 the way we did it before using the distributive property, this is what you'd get for an answer. But the reason we're doing this with algebra tiles is because we're going to use algebra tiles to start factoring these trinomials. So when you multiply x squared plus 4x, x plus 1 by x plus 3 together, you get x squared plus 4x plus 3. When you multiply x plus 3 and x plus 1 together, you get x squared plus 4x plus 3. So that tells us then the factors of x squared plus 4x plus 3 are x plus 1 and x plus 3. Remember, factors are things that multiply together to get what you start with. We multiplied x plus 1 by x plus 3. We did it using algebra tiles. We could have done it using distributive property. Wouldn't matter. We'd get the same answer, x squared plus 4x plus 3. But that also means that you can go backwards and say, if you start with x squared plus 4x plus 3 and you want to factor it, the factors are x plus 1 and x plus 3. Okay? Factoring and expanding are opposite operations. When you factor, you're finding things that multiply together to get what you start with. If you multiply out the factors, you will get what you start with, and it goes both ways. We can factor x squared plus 4x plus 3 to give us x plus 1, x plus 3, or we can take x plus 1, multiply by x plus 3, and you'll get x squared plus 4x plus 3. So again, we're doing this because we're going to initially start by using these algebra tiles to factor these trinomials. So let's go on to the next one where we want to factor x plus 2 and x plus 4. So I'm going to put the x plus 2 on the top. So that'll be a positive x And then +2 means 2 +1 tiles. And on the side, I'm going to put x plus 4. So I'll put the positive x on the side. And then for the +4, it'll be 4 +1 tiles. So there's positive x plus 4. So you should be coloring these in right now. Because we're then going to use this same method so that we can factor these trinomials. So you're going to fill in all the spaces now with a shape that's the same width as what's above it, the same height as what's beside it. So that first one, again, the same width as what's above, the same height as what's beside, will be a big x squared. And again, all of these tiles will be colored because in every case it's a positive times a positive. So each space will be filled in with a shape that's the same width as what's above, the same as height as what's to the side. Same width as what's above, same height as what's to the side. Same height as what's above, the same height as what's to the side, I should say, same width as what's above. So we fill in all the spaces with a large rectangular shape. And if we look at the value of all these shapes together, you've got 1 positive x squared. There are 6 positive x tiles, and there are 8 +1 tiles. So when you multiply x plus 2 by x plus 4, you're going to get x squared plus 6x plus 8. This also tells us is that the factors of x squared plus 6x plus 8 are x plus 2 and x plus 4. Remember, factors are things that multiply together to get what you start with. If you multiply out x plus 2 by x plus 4, you'll get x squared plus 6x plus 8. So that means the factors of x squared plus 6x plus 8 are x plus 2 and x plus 4. Again, normally we would just use the distributive property to multiply those two binomials together. We're doing it using algebra tiles because we're going to then start to use algebra tiles to factor these trinomials. And you might start to recognize what's special about these trinomials. Number one, they only have one variable in it, in this case the variable x. The second thing is that it's an x squared term, then an x term, then a constant term. Same thing as the last one. X squared plus 4x plus 3. It was an x squared term, an x term, and a constant term. So these are the types of trinomials that we're going to learn how to factor. This next one will have a negative part to look at. So it doesn't matter whether you put the x plus 2 on the top or on the side. It doesn't matter. But if I put positive x plus 2 on the top here, so there's our positive x, there's our plus 2. On the side, we're going to have a positive x as well, but then we're going to have a minus 1. So for that minus 1, that is one of the uncolored small tiles. But you're going to start to fill in the spaces with tiles that are the same width as what's above, the same height as what's to the side. Well, now we'll also make sure that we use the right colored tile, because if you multiply a positive times a negative or a negative times a positive, you're going to get a negative. But the first one is multiplying a positive by a positive. Again, same width as what's above, same height as what's to the side. This first row, they will all be positive, same width as what's above, same height as what's to the side. But this bottom row, they're all going to be negative tiles because you're multiplying a positive by a negative in every case. Same width as what's above, same height as what's to the side. But in each case, you're multiplying a positive times a negative, which means these are going to be negative tiles. But again, it's the same width as what's above, the same height as what's to the side. And so now when we write the value of our polynomial, you're going to have a positive x squared. You're going to have two positive x's, but one negative x tile. And then you have two negative 1 tiles. 2x take away 1x is 1x. So there's the answer. When you multiply those two binomials together, you get x squared plus x minus 2. So that means the factors of x squared plus x minus 2 are x plus 2 and x minus 1. Factors are things that multiply together to get what you start with, and we multiplied those two binomials, Cheney. You on your phone? Put it away, please. We multiply those two binomials together to get that trinomial. So if you factor the trinomial, you're going to get the two binomial factors. Again, this trinomial has an x squared term, an x term, and a constant term. These are the types of factors we're going to learn how to factor first using algebra tiles, and then we'll start doing them by using an algebraic method that I'll teach you. Okay? Here we're going to multiply x minus 3 by x minus 2. It's a positive x, but negative 3 means we need 3 negative 1 tiles. And on the side, we're going to have a positive x minus 2, so now we need 2 negative 1 tiles. So now we're going to fill in all the spaces with tiles that have the same width as what's above, the same height as what's to the side. Also, remembering that if you multiply a positive by a positive, you're going to get a positive. If I finish this top row, I'm going to have a positive on the side by a negative above. Those are all going to be negative tiles. A positive times a negative is a negative. A positive on the side, a negative above. When I start to fill in the left side here, below the big square, it's going to be a negative times a positive, which again is a negative. So these tiles are going to be negative because it's a negative on the side times a positive above. But the remaining spaces will all be found by multiplying a negative times a negative. They're all going to be positive tiles because you're multiplying a negative on the side by a negative on top. A negative times a negative is a positive. And again, each of these shapes will be the same width as what's above, the same height as what's to the side. So we've created a rectangular shape, I should say. And if we look and see what we have here, we've got a positive x squared. In this case, there are 5 negative x tiles, so that's minus 5 x's. And then there are 2, 4, 6 positive 1 tiles, so that's positive 6. That's what you get when you multiply those together. Again, we did it using algebra tiles. We could have done it using distributive property. We would have got the same answer. But we're doing it using algebra tiles because we're now going to be using algebra tiles to help us factor these trinomials. So again, that tells us that the factors of x squared minus 5x plus 6, those factors are x minus 2 and x minus 3. We because we multiplied them together to get x squared minus 5x plus 6. So that means if you factor x squared minus 5x plus 6, you'll get x minus 2 and x minus 3. Those are the two factors. Okay. So now we're going to use algebra tiles to help us factor these trinomials. We want to find the factors for x squared plus 3x plus 2. So if you look at what we did on the previous one, we were given the binomials first. We put them on the top and on the side, and then we filled it in. And what we filled it in with gave us our answer. So now we're going to be working backwards. We're given the answer, so we need to fill in the inside part and then look and work backwards to see what the two things on the outside will be. And we're going to create this trinomial x squared plus 3x plus 2. We're going to create it by using algebra tiles and making sure that we have that rectangular shape when we're done. So the first term is positive 1x squared. So that's always going to go in the top left corner, just like we did when we built or multiplied out our binomials in the last 4 or 5 examples. We got that x squared term in the top left, and we also had the 1 tiles in the bottom right. So here, the last term is plus 2, which means we have 2 positive 1 tiles. And you're always going to form a rectangular shape. So you can either put the positive 2, the 2 positive 1 tiles side by side like that, or you could also put them vertical like that. It doesn't matter. Well, sometimes it doesn't matter. Sometimes it does. And we'll see an example where maybe it does. But let's put it the way we originally did it. Now, we have to build our positive 3x's, which is nice because we have 3 spaces left to fill in. We've got the 2 spaces that are above the positive 1 tiles and the 1 space to the left of the positive 1 tiles. Remember, we want to build a shape so that it's a rectangular shape at the end. So we're not going to have any extra pieces on one side or the other. So there's my positive 3 x tiles. So I have 2 to the right of the x squared and 1 below the x squared. And then I've got my 2 positive 1 tiles there. So once again, I've created an x squared plus 3x plus 2. I've got that rectangular shape. So if I go backwards then, right, this tile here has a width of x and a height of x, and these two to the right of the big x squared both have a width of 1. So it'll be a plus 1 and a plus 1, which is plus 2. That's how wide they are. They are 1 unit wide. On the bottom, again, I've already got this x on the side. And on the bottom, all these tiles have a height of plus 1. Right? It's a plus because those are all positive tiles and they have a height of 1. So you can see again, this x squared comes by multiplying x times x. So that's why I put x's there. Right? This tile is x wide and x high. These 2 tiles are positive 1 wide, and there's 2 of them, so that's where my plus 2 came from. These tiles are all positive 1 high, and that's where my plus 1 came from. So I'm saying then that the factors of x squared plus 3x plus 2 are x plus 2 and x plus 1. That's what we're saying. The factors of x squared plus 3x plus 2 are x plus 2 and x plus 1. They sound very mad, so hopefully it's nothing too serious. All right. Remember, you can always check. Factors are things that multiply together to get what you start with. So you can always check your factors. If you multiply x plus 2 and x plus 1 together, you should get, Brock, put your phone away. You should get x squared plus 3x plus 2. So let's check this by multiplying using the distributive property. Factors are things that multiply together to get what you start with. So we're going to check to make sure when we multiply them together, you get what you start with. So that'll be x squared plus 1x. Then we'll have a positive 2x and a positive 2 when we multiply those out. When you collect the 1x and the 2x together, you're going to get 3x. When we're done. Shouldn't be too much longer. But you had an hour to do the bathroom, so you could have done it then. Right, the lesson's important. I'm explaining how this works, so it's important that you're here for this. So our factors are correct. Remember, factors are finding things that multiply together to get what you start with, and that's what we did. We multiplied x plus 2 and x plus 1 together. It gave us what we started with. So we have just confirmed that these are the correct factors. We just checked them. And we did it by using algebra tiles. Again, I'm going to show you also how to do it without algebra tiles, how to do it algebraically. But algebra tiles work as well. Okay? So next, we've got a trinomial, x squared plus 6x plus 8. Again, these are the same type as what we've been working with, right? There's an x squared term, there's an x term, and there's a constant term. Brock, this is the last time I'm going to tell you, and then you're going to the office. Yeah, I'm serious. Stay off your phone. I will, next time. If you want to go now and talk to your vice principal about it, well then, don't push me. No, you're not. You're on your phone. You're looking down at your phone. You cannot pay attention when you're looking at your phone. And you do know that is a rule at this school. You're not supposed to be on your phone in class, right? You do know that's a rule. Do you not? I'm asking you a question. Okay, so we shouldn't have this constant debate about it. Every time you're on your phone, we do. I'm sorry? I will, next time. And I don't care what other teachers do in their class. I really don't care. If some teachers let you be on your phone the whole class, that's between you and them. This is my class, and you're going to follow the rules. So we need to build x squared plus 6x plus 8. Again, those are all positive terms, so we're going to use positive algebra tiles. So there's your positive x squared. So again, the x squareds always go in the top left-hand corner. We're going to eventually see ones where you might have 2x squared, so you're going to put 2 of those in the top left-hand corner. The positive tiles, the positive 1 tiles, I should say, in this case, all the 1 tiles always go in the bottom right-hand corner. So we need to build positive 8. And remember, it's always going to be a rectangular shape. So the 2 options will be 4 wide and 2 high, or 2 wide and 4 high, because they have to form a rectangular shape altogether. Sometimes it won't matter how you place these. Again, in this case, I went 4 wide and 2 high. As I said, they also could be 2 wide and 4 high. Sometimes it doesn't matter how you place them. Sometimes it does matter, because we need to fill in the remaining spaces to make a positive 6x, right? Each of the remaining tiles will be x tiles, because they have to be the same height as what's beside, the same width as what's above, or the same height as what's to the side, and the same height as what's to the side, and the same width as what's below, depending on where you are. But we need to build positive 6x's, which works out great because there are 6 spaces to fill in. There's 4 spaces above the 1 tiles, plus 2 spaces to the left of the 1 tiles. Remember, all these new tiles will have the same width as what's beside it, and the same height as what's either below it, or the same width as what's beside it, and the same height as what's below it. Depends how you look at it. So if we fill in the remaining spots, it's going to look like this. All these 4 tiles here will have the same height as what's beside, the same width as what's below. These 2 down here will have the same width as what's above, the same height as what's beside. So what did we build here? Well, this big x squared tile comes from multiplying x times x. It's x wide and x high. These 4 tiles are all 1 unit wide. So you've got a +1 there, a +1 there, a +1 there, and a +1 there. Those are the width of them. That gives us +4. To the side, this is 1 unit high and 1 unit high. That gives us +2. So those are our factors. We're saying that the factors are x plus 4 and x plus 2. That's what we're saying. Remember, factors are things that multiply together to get what you start with. We're saying the factors are, Princess, put it away. Just put it away. X plus 4 and x plus 2. And we can check. If we're saying those are our factors, factors are things that multiply together to get what you start with. So if we do multiply them together, we should get what we started with. So this is our check. Using distributive property, it looks like this, which, by the way, this will be on your quiz tomorrow. Multiplying binomials times binomials. So this is like a review for tomorrow's quiz. This is one of the things you're going to have to do on that quiz. Multiply binomials together, and we do that using distributive property. So when you multiply them out, you'll get that. When you collect the 6x and the 4x to get, the 2x and the 4x together, you will get 6x, which is what we started with, x squared plus 6x plus 8. So we have just shown that these are the correct factors. We've just shown that by checking. So this next one has a negative term in it, a -2 at the end. Doesn't change the way it's done. So we need to build that trinomial, x squared plus 1x minus 2, inside this diagram. Remember, the x squareds always go in the top left. So there's my positive 1x squared. And then I need to build -2 in the bottom right. So that is 2 -1 tiles. And you're either going to put them 1 high and 2 wide, or 2 high and 1 wide. Sometimes it doesn't matter, sometimes it does. But if you look what we have left to fill in, we have to create this positive 1x, and we have 3 spaces to fill in. We have 2 spaces above the -1 tiles and 1 space to the left of the -1 tiles. We have 3 spaces to fill in with x tiles, but together they have to become positive 1x. And that will only work if we have 2 positive 1x tiles and 1 negative x tile. The 2 positive 1x tiles minus the negative 1x tile will give you plus 1x tile. One of the positive ones will cancel with the negative, and you'll be just left with 1 positive x tile. So you see what we did. We built this rectangular shape. Right? We've got the x squared in the top left, we've got the 1's in the bottom right, but also notice I have all the positives in one row and all the negatives in one row. They're all together. That's going to be the easiest way to do it. It also allows us to write our factors. On top, we have a plus x width, and then we have 2 positive 1's wide, so that'll be positive 2. On the left, we have a positive x high, and this tile on the bottom, all these tiles, in fact, are 1 high, but they're negative ones because all of these tiles are not colored in. So we're saying the factors are x plus 2 and x minus 1. And it doesn't matter which factor you put first. You could put the x minus 1 first and the x plus 2 second. It doesn't matter. We're saying that these are our factors. To make sure, we will check. We will physically multiply these out and make sure that it gives us our original trinomial that we started with. So again, we multiply these out using the distributive property. so there's x squared minus 1x, positive 2x minus 2, and once again, negative 1x plus 2x is positive 1x. That is what we started with, x squared plus x minus 2. So we have just shown that these are the correct factors. Factors are things that multiply together to get what you start with. We have just shown that those are the correct factors because they do multiply together to get what we started with. Right? We went from a sum and difference of terms to a product of two factors. That's what we did. So what about x squared minus 2x minus 8, Jan? We need to build that trinomial inside that shape. So we need a positive x squared. The x squareds always go in the top left. And then we need a negative 8 in the bottom right. That will be 8 negative 1 tiles. And again, you're going to create a rectangular shape. Eight negative 1 tiles. So there's two options here. It can be 4 wide and 2 high, or it can be 2 high and 4 wide. Sometimes it matters, sometimes it doesn't. You don't know unless you try. But they have to form a rectangular shape. So you wouldn't have, let's say, a row of 6 and then a row of 2 underneath, because that's not a rectangular shape. So look at how many shapes we have left to fill in. How many do we have left to fill in, Brock? Pardon? Okay. Where are those 6? Okay, that's 4 of them, and then the other 2 are beside. Okay, we need to form negative 2x. And remember, you want to keep all the positive and all the negatives together. So how would we do that part, Brock? Okay, we need to create our tiles so that they equal negative 2x. We need to keep all the positive x's together and all the negative x's together. So how would we do that? No, I know you're not the stupidest person in the class. I know that. Yes. Right. Because you want to keep them together. You want to keep all the positives together and all the negatives together. And we have 4 spaces above the ones, and we have 2 spaces beside the ones. And again, they have to equal negative 2x. So we need to use 4 negative and 2 positive x's. We must do it that way. We need 4 negative x's and 2 positive x's. So you can see what we've done. We've built this rectangular shape. We've got the x squareds in the top left. We've got the 1s in the bottom right. All the positives are together. All the negatives are together. Right? All the positives are on the left side here. All the negatives are to the right of the positive. They're all together. So Brooklyn, what are the factors then? Say again? X minus 4, you said? Is that it? You agree with that, Princess? Why not? No, she's right. This is x wide. That's where the x came from. And there are 4 negative 1s. That's where the minus 4 comes from. A width of negative 1, a width of negative 1, etc. So we're saying that these are the factors. That should have been an x minus 4, so I will fix that. We're saying those are the factors. And remember, factors are things that multiply together to get what you start with. So if we check them, they should equal x squared minus 2x minus 8. So here's our check. We're actually going to multiply out x minus 4 by x plus 2 using the distributive property. So multiplying out, you'll get x squared plus 2x. You'll have negative 4x minus 8. 2x take away 4x is minus 2x. That is what we started with, x squared minus 2x minus 8. So we have just confirmed that these are the correct factors. That's what we've done. We confirmed that those are the correct factors. That is what multiplies together to get what you start with. Let's skip the next one and go on to 2x squared plus 3x plus 1. So I said we're going to see one like this, where instead of just 1x squared, there are 2x squared. But this is the same type. You've got an x squared term, an x term, and a constant. Remember, the x squareds always go in the top left. So in this case, we have to put 2x squareds in there. The x squareds go in the top left. The 1's go in the bottom right. And in this case, there's just a positive 1. 1, positive 1 tile. Keen, how many spaces do we have left to fill in?
3.
That's right. And what do they need to make? What do those 3 spaces need to make? No, they need to make this positive 3x. So we have 3 spaces that have to make positive 3x, so that is easy. We will use 3 positive x tiles. Each tile will be the same width as what's above, the same height as what's beside. That's how we know to fill in these 2 x's. This one up here is the same height as what's beside, the same width as what's below. So if we want to write the factors, we've got this one here is xy, that one there is xy, that one there is positive 1y. That means this is 2 x's plus 1. On the side, it's x high and 1 high, so that is x plus 1. We're saying those are the factors. We're saying that 2x plus 1 and x plus 1 are the factors. Can we check that, Riley? Can we check to make sure that they are the correct factors? How? By multiply, that's right. This is our check. We're going to multiply 2x plus 1 by x plus 1. So what will that look like if we multiply all of those out? Emery, what will that look like? What would our next step look like? Remember? Olivia, can you help her? How do we multiply those out? What would we write down next? Did you say 2 times x? Two x times what? 2x times x plus 1. You're going to multiply the 2x by the entire binomial that's written down second. Anything else? Can you help her, Jan? Plus 1 times x plus 1. So we're multiplying both terms in the first bracket by the second bracket, right? That's what we did for distributive property. So this will give us 2x squared plus 1x plus another 1x plus a 1. 1x plus another x gives us 2 x's. So that something's not right there. Oh, I know. Oh, that's right. So I've got 2 x's plus 1, and on the side I've got x plus 1. This should have been a 2x because it's 2x times 1, which is 2x, not 1x. So that'll give us 3 x's when we combine those. So again, this kind of shows why this check is important, because you're making sure. Even though I made a little mistake there and it made it so that I didn't get what I started with, so I had to go back and check. And I found out where my mistake was. So we have just shown that these are the correct factors. They do multiply together to get what you start with. We've shown that. Try this one on your own. We're almost done. We're almost done. So the x squareds go in the top left. So you can either build the 3x squareds like that, 1 high, 3 wide, or you can do it the other way, where they're stacked on top of each other. But they stay together. Now we have -6 to build in the bottom right. So that will be 6 -1 tiles. And again, they're going to be in a rectangular shape, which means it's either 3 wide and 2 high, or 2 wide and 3 high. Sometimes they can be done either way, sometimes not. You don't know unless you try. If you can't get them to work one way, you'll get them to work the other way. So how many spaces do we have to fill in here? That's right. You've got 6 below, 1, 2, 3, 4, 5, 6, and 3 on top. So we got to build a positive 7x with 9 tiles. Now, the only way that would work is if you had what? You can only have 9 tiles to fill in, and they have to build 7 x's. How would that work? Could it work? Some are going to be positive, some are going to be negative, right? There's going to be more positive than negative. If you did 7 and 2, that won't work, because if you have 7 positive x's and 2 negative x's, yes, you've got 9 tiles, but they actually become 5x, not 7x. If you have 8 positive x tiles and 1 negative x tile, well, that'll work as far as getting us 9x or 9 tiles, making 7 x's. But the problem is with that is that you're going to have some positive and negative tiles together. Okay, all the ones down here have to be the same color, and all the ones on the side have to be the same color. So what that tells me maybe is that the way I have my -1s placed, it might not work. I might have to change the way they are arranged so that they're 2 wide and 3 high. Now I've got 3, 6, 9 tiles that go down below, and 2 tiles that go above. And 9 take away 2 is 7. So if I put 9 positive x tiles down below, and 2 negative x tiles above, nine x take away 2x gives you my 7x in the middle. I've built a rectangular shape. I've got my x squareds in the top left, my 1's in the bottom right, and I've got all my positives together and all my negatives together. So Sal, what's the factor we would write on the top? Yes? Yeah. We're saying those are the factors. How can we find out if they are the factors, Declan? (3x by x plus 3) and negative 2 times what? No, the negative 2 is from the 3x minus 2, x plus 3. This is our check. We're going to multiply them together. So that gives us 3x squared. That gives us our positive 9x's. Then we have our minus 2x's and our minus 6. Again, 9x take away 2x is positive 7x. We just checked. Our factors are correct. Right? That is the original trinomial that we started with. So we know our factors are correct. Okay, so you got some practice to do on page 234. Questions 1 and 2. Remember, tomorrow you have your quiz. It does not include what we learned today about factoring trinomials using algebra tiles. That's not on the quiz tomorrow. Quiz tomorrow will just be multiplying polynomials, which we did some practice with that today, and also factoring using a common factor. So you need to spend some time getting ready for that. Some of you still have some assignments to hand in, so you got to get those in. Before too much longer, I'm going to start putting some zeros in, so your mark's going to drop. Get those assignments in. Okay? So I'll post the solutions to these questions on Google Classroom so you can check your answers.